Hello everyone. In today's lecture we will discuss about the first order infinitesimals, and now we want to revisit the idea because here we will define the total differential operator. And what will be the benefit of defining total differential operator? Definitely students, in the previous lecture I have told you that we want to find the value of y xx and y triple x because we want to find the invariance of second order and third order linear ordinary differential equations. Okay. Now students, we know that y of x, the value of yx, while we were defining the least invariance condition for the first order equations, then you can also see that while we were proving the least invariance condition, we have derived this value, that is y of x is equal to yx plus y prime minus x of x y prime minus x of y prime square. Now if we simplify it further, then we can write it as this one, and here I have just plug out the value of y prime as common. Now students, if we define the total differential operator as this one, like dx is equal to partial by partial x plus y prime partial by partial y. Now you can see that if I write the value of dx as students, if I apply the total differential operator on capital Y, then obviously I will write it down partial capital Y by partial x plus y prime partial capital Y by partial y. Okay, and then after that we can write it as this one, like dx of capital Y is equal to y of x, because y is in terms of two variables x and y, so that's why we are taking its partial derivative, and in the similar way we can write it as y prime and partial derivative of y with respect to y. So I can write instead of this value only dx of y, because this is the value of this operator. Okay, and in the similar way we can write down here dx of x into y prime as it is. Now we call y of x an extended infinitesimal. Now consider dy bar by dx bar using the total differential operator d. Therefore, like if we want to find dy bar by dx bar, then obviously y bar and x bar are the infinitesimals. So you just need to substitute their values, like you can write y plus epsilon, capital Y plus order of epsilon square, and this is actually the value of y bar, and in the similar way you can substitute the value of x bar, that is equal to this one. Now students, if you want to take the the derivative of this term, then you can write it as like this one. You want to take the derivative of this term, then definitely here you will write dy by dx plus epsilon as it is, and y is in term of two variables x and y, so you will take this partial derivative with respect to x and then the total derivative with respect to x. In the similar way, the partial derivative with respect to y and the total derivative plus order of epsilon square. And in the similar way, if you take the derivative of the denominator, then it will become equal to 1 obviously, and plus epsilon, and in the similar way you will take the partial derivative of this term plus order of epsilon square. And these are exactly the values of, like here you will get 1, and this is the value of dx of capital Y, and this is the value of dx of capital X. Okay, so you get this term. And after that, if you take this value in the numerator, then definitely its power will become equal to -1, and if you expand by using the expansion, then you will write it down as this one, and you can take the higher order terms in the order of epsilon square. Now students, if you multiply both of them with each other, and you can take the values of epsilon square and all the higher order terms, that is in terms of epsilon in the order of epsilon square, then you can write it as this one. And this is what you have already written down. This is the value of y of x in the total differential operator. Okay. Now students, in this lecture we have revisited the idea of first order infinitesimals, and we have defined the total differential operator. Now in the next lecture I will discuss about the second order infinitesimals, and we will derive the least invariance condition for the second order ordinary differential equation, and we will see that how the total differential operator will help us in simplifying the calculations. So thank you so much.